It's impossible to stay still in the universe, and actually, it's impossible to go slower than the speed of light. So right now you are moving at 299,792 kilometers per second. Let me explain how. You see, our universe is made up of 4 dimensions, 3 spatial dimensions and 1 time dimension. Time and space are not separate from each other. Time is the 4th dimension. And everything that appears to stay still is moving through time at the speed of light, including you. Non-moving objects experience time at a rate of 1 minute per minute. So congratulations, you are a time traveler as well. Sure, it might seem a bit mundane, but this is just the starting point. The real fun begins when we talk about the concept of time travel as you know it from science fiction, like for example shaking hands with Einstein or riding on laser raptors. Moving at light speed doesn't necessarily mean to go from point A to point B in space. It could also mean moving through time. 3 spatial dimensions and 1 time dimension combined is what we call space-time. Time isn't just something that passes. When you feel time passing or experience events happening in your life, what's really going on is that you're moving through the time dimension. However, this dimension can feel a bit of a letdown because unlike in space where you can move forward, backwards, left, right, up and down, in time you can only move forward. You get older, not younger, and you can't take detours to the past. But here's the twist. This feeling of being stuck moving only forward in time is just an illusion. You actually have more control over your movement through time than it seems. To explain how this works without jumping into complicated math, we'll need to simplify things a bit. So if there are any physicists who are watching this, please forgive us for bending the truth a little. This is where things get really interesting. There's a strange rule in our universe that says everything moves at the speed of light through 4-dimensional space-time. Your speed through time is actually the sum of your speeds through space and time. This means it's impossible to stay completely still. You're always moving through time dimension, hurtling into the future. Now you can slow down your movement through time dimension by speeding up your movement through space, but no matter how you divide it, the total sum of your speed through both space and time will always add up to the speed of light. For instance, if you could somehow stand completely still in space, you'd still be moving through time at the speed of light. On the flip side, if you were to move through space at the speed of light, your movement through time would essentially stop. This is exactly what happens with photons, the particles of light. They move through space at the speed of light, but they don't experience time passing at all. Their speed through time dimension is 0. From the photon's perspective, it doesn't see time. When light travels from sun to your eye, it's as if nothing happened in between. Now keep in mind, we're simplifying things a bit. In reality, things are more complex. For example, you can't really be perfectly still relative to the universe itself. You can only be still relative to other objects in space. Plus, photons don't have a clear reference of frame like we do, making their experience of time tricky to define. But the core idea remains that we're still moving through space-time at the speed of light. So everything in the universe moves at the same breathtaking speed through space-time, but this speed is split between space and time. This splitting leads to some fascinating consequences, including time travel. There is a way for real and easy time travel. Let's start with a simple example. Imagine a bus driving past you. The bus is moving a bit faster through space than you are, so it moves slower through time relative to you. The idea here is straightforward. The faster something moves through space, the slower it moves through time, and vice versa. If someone were moving much faster or slower than you, you'd both end up traveling different distances in time dimension. One of the most famous illustrations of this is the twin paradox. Imagine forcing one twin into a rocket and sending them on a high-speed journey through space, while the other twin stays on Earth. Because one of the twins is moving so fast through the space, they are moving slower through time compared to the twin on Earth. When the rocket returns, the traveling twin will be younger than the twin who stayed on Earth. This isn't just a quirky thought experiment. It's a real consequence of how time works in our universe, known as time dilation. With a fast enough rocket, you could theoretically travel far into the future. You could even witness the end of the universe if you moved quickly enough. But let's talk about another way to travel forward in time. Time travel can also occur near massive objects. The massive objects like planets or black holes bend space-time, causing time to pass more slowly near them. On Earth, this effect is tiny. Time passes just 0.00000007% slower on Earth than it does in dim space far from any gravitational fields. While this is barely noticeable and not very useful for time travel, it demonstrates the main principle of how gravity affects time. However, if you were to move near a much stronger gravitational field, such as around a black hole, time would slow down even more dramatically. If you brought that twin near a black hole, time would pass so slowly for them that from an outside perspective, it would seem like they were almost frozen in time. Once they left the black hole's gravitational field and returned to Earth, they would realize they had traveled into the future. These scenarios illustrate how the universe allows for some pretty mind-bending time travel possibilities, even if they're not quite as convenient as hopping into a time machine. So you can travel to the future by moving at high speeds or staying near a black hole, but this method has its drawbacks, except for those who just want to teleport to the future. It also makes creating a vast human space empire very difficult. No matter how advanced our technology becomes, any long journey to the distant stars would mean leaving behind your home forever as you knew it. However, with this knowledge, there might be a way to use the laws of our universe to travel back in time. The past is like a distant land. Let's explore it. Since you always move through space-time at the speed of light, going faster through space slows you down in time. This provides a potential opportunity for traveling backwards through time. The theory of relativity, one of the most robust scientific theories we have, does not prohibit faster than light travel through space. Well, it actually does, but the space itself can expand faster than the speed of light. So could we one day learn to manipulate space then and somehow use this to travel faster than light? Well, the hypothetical Alcubierre drive suggests that within Einstein's relativistic field equations, there is a theoretical solution that could potentially allow faster than light travel. By expanding space behind it and contracting space ahead, a bubble of space could move between the stars at incredibly high speeds. However, if you were to move through space at superluminal speeds, faster than light, you would have to move through time dimensions with a negative velocity. This means you would travel backwards in time relative to the rest of the universe. Scientists have even proposed the existence of superluminal particles called tachyons, which could possess extraordinary properties such as speeding up as they lose energy and of course traveling back in time. This would be genuine time travel, similar to photons. It's challenging to define how time passes for tachyons themselves. It all depends on how you move through space-time relative to them. But now, for the first time, some observers could potentially witness tachyons literally going back in time, which could allow them to interact directly with the past. In theory, you could use them to send messages to your past self and change events that have already happened. Imagine using tachyon-powered sci-fi technology to hack yourself back in time and watch the formation of the Earth, meet your grandparents, prevent yourself from making that one regrettable mistake, win the lottery, or even get eaten by the laser raptors. Of course, this would also create mind-bending time paradoxes that could potentially disrupt the universe itself. But the theory of relativity specifically forbids anything that starts slower than the speed of light from ever reaching it. Moving faster through space requires energy, and the amount needed to reach the speed of light is literally infinite. Even if you could harness all the energy in the universe, you couldn't accelerate even a grain of sand to the speed of light. You can get very close, but you can never actually reach it. Photons, for example, always move at the speed of light, but they never travel any slower. Similarly, if something moves faster than light, superluminally, it would always move at that speed. Unfortunately, we don't have any evidence that tachyons actually exist. While they work on paper, most of the scientists believe that they aren't real. For now, it seems that traveling into the past is strictly impossible, no matter how much we might wish otherwise. The past remains a distant land that one can view through memories, photographs, and videos. But in a way though, a photograph is like a ghost. It stole something from reality. Something, but not all of it. It's not a piece of reality plucked out of the sequence of time, but only a small shadow of a particular moment in reality. Think about it. If you could hack yourself back to the year 2001, you could influence or fix some of the events that happened that year. You could go to Australia or Dubai and you could experience how the world was like before the smartphones. Or you could go to New York and change a few things here and there. But with the photograph, you can't do that. If you have a photograph from a particular moment in 2001, that photograph can't tell you what was happening anywhere else in the world or let you disturb or disrupt it in any way whatsoever. It's only an interesting pattern that remains after some photons hit a lens in a particular manner. It is just a tiny window into the past, offering a glimpse of an era that is forever beyond our reach. While this might seem disappointing, it leaves you with the most important time of all, the present moment where you truly exist, and the future that's yours to shape. And if you wish, you could even time travel to it. And with that, press the bell icon, stay curious, and see you next time.